Hello everybody, my name is Maria and I'm doing an industrial PhD with TECNALIA Center and the University of the Basque Country. And currently I'm doing the international stay in the Technical University of Denmark. My thesis is focused on the preliminary design phase of the floating offshore wind turbine substructures. So offshore wind means to have a higher power capacity factor so we can build bigger turbines to obtain more power from wind. Currently, fixed foundations are the most common ones, although they are limited to shallow waters. So that's why it's so interesting to go to floating. We can install them in deeper waters and having access to the 80% of the marine source. There are many type of different substructures for floating, but this work is focused on the semi-submergible ones. For the design of the offshore floaters, many load interactions have to be accounted for, such as wind, wave, current, earthquakes, ice, so it requires a dynamic time domain simulation. They are very complex, so they are very time consuming as well. So, for preliminary design, it's important to have a fast tool which enables a quick comparative analysis of many different platform designs subjected to a wide range of environmental conditions. And based on a predefined requirements, the tool would identify the few concepts that fulfill these criteria. So we can choose among a small number of designs which ones to be analyzed in time domain. This is what I'm working on. This tool is composed of three different modules. One hydrodynamic coefficient estimation module, which enables to estimate the hydrodynamic coefficients for new geometries without the using of commercial softwares. Also, the second order hydrodynamic loads module based on the accelerated method from DTU, but with the extension to the semi-submergible floaters. And last but not least, the response calculation tool, which is a simplified 4 degree of freedom model based on frequency domain, and it's based on the QLab from DTU as well, with some modifications to make it faster. So with this tool, we can also obtain some knowledge, such as defining like the design criteria for floating offshore wind substructures, to study the peak load underestimations due to frequency domain, or to obtain some scalability laws for the substructures for bigger turbines. So I think this is a quite interesting tool, which we can obtain a lot of knowledge from it, and it's fast, focused on semi-submergibles, and with improved and extended modules. So I hope you enjoyed the video, and thank you very much for your attention.